Okay, 4.3, if you look through your review sheet, has all the theorems and has the first and second derivative test. The first derivative test, there's f prime. If the derivative goes from positive to negative, then my function could be doing this. Okay, guys? J? If that's 0. You know what else, though? I could do this. F prime, and it goes undefined there, positive to negative, assuming it's a continuous function, then it might look like this. Okay? It's still a maximum, but the fact that it's undefined gives me a sharp corner. Actually, it would look weird. Like it wouldn't look like that. It would look like, see, it would be a positive slope, and then it would be a negative slope with an undefined. So it actually looked like that. Look like that one. The slope's positive, that's negative, that's undefined. Now, if you know that your derivative goes positive, 0, negative, you really don't need the second derivative because it's always going to be smooth like that. It's going to dictate the concavity. Okay, let's look at another test. You may use either test. However, on the exam, sometimes you're forced to use the second derivative test. If you look at some of the multiple choice questions, you'll find it. Okay, so let's look at this. This is obviously what at C? Maximum or minimum? It's a maximum. Now, the second derivative, what would be true about the second derivative? This is concave down. No, it's not 0. The second derivative, if it's concave down, has to be less than 0. Ends up being counterintuitive to me, at least. I want to switch those, so I just draw the picture. I don't memorize it. Here's C. This is a what? Max or min? Min. What's true about the second derivative there? Adam? Concave up, so what's true about the second derivative? Greater than 0. It's a lot easier if you listen. Okay, that's the second derivative test. That's all there is. What you do is you find your critical points, Ricardo. You find your critical points, and you evaluate them in the second derivative, and f double prime of x. If it's positive, it's concave up, and it's a minimum. If it's negative, it's concave down, and it's a maximum. If it's a 0, I know nothing. Ricardo, Jay. If buy one. There's a spot right up here. Guys. Okay, guys. Let me say this again. Okay, guys. You find your critical points. So you do have to find the first derivative. You evaluate those points in the second derivative. If the second derivative is positive, then it looks like concave up. So you have a minimum. If the second derivative is negative, Adam, put that away, please. Then it's concave down, and it's a maximum. What if it's 0? We know nothing. What if it's undefined? We know nothing. If you have a second derivative is positive at your critical point, then it's the function's concave up, and we have a minimum. If you have a second derivative that's positive, that means the function's concave up. Look at the picture. That's a minimum. So let's do a problem. Now here's the lingo for this, by the way. If you want it. Okay, let's do this problem right here. Now, when you do these problems, be careful. When you do these problems, be careful. Read the problem carefully. This is the first derivative. They could give you something like, oh, no, you still could do a derivative test. We'll do a first derivative test. They could give you just the second derivative and critical points and ask you if it's a max or min, which means you have to use the second derivative test. Okay, Cameron? Nick? Okay, so let's do the problem. what am I looking for to start with? I'm going to find the critical points. So how do I find those? Is f prime ever undefined? No, because nice polynomial. So let's set it equal to 0. Can I factor something out of that? 4x squared. I'm left with x minus 3. Cole should be doing this with us. In other words, write down. Watching doesn't do any good. I watch basketball, I watch golf, I watch football, I can't do any of those things. Well, I play golf, but not that well. Okay, let's just do a first derivative test. Where are critical points? X equals 0 and 3. Those are the points you would evaluate in your second derivative. Cardo. So I'm going to draw my little graph here, f prime, and I'm going to put in 0 and 3. That's a 0, and that's a 0, and then I'm going to test my regions. If I know what that cubic looks like, I have an idea, because what's going to happen to x squared? Do you guys remember functions bouncing on the x-axis?
What?
Yeah, because it's always positive. But let's go ahead and test regions. Let's say we can't do anything better than that. So let's try 10. Is this positive or negative?
Positive.
What's the easiest number between 0 and 3 to test? 1. If you put 1 in there, that's always positive. 1 minus 3 is negative. I don't care what you put in here. If it's a negative 100, it's still always positive. But this is negative. Negative 100 minus 3 is negative. Now, I actually know what this function looks like without any more thinking. Well, let's see what it's doing. What's my function doing here? It's decreasing. It zeroes out, and then what does it do? And since that's not undefined, I can't put a sharp corner. Concavity is going to have to change there. And then it's going to decrease, and then it's going to increase. Is this a maximum or a minimum? Minimum at x equals 3, because f prime goes from negative to positive. That's the first derivative test. The second derivative test, I could have bypassed that, except I do have to find these critical points. What's f double prime of x? Carolyn, Allie, what's the f double prime of x? Let's take the derivative. What's the derivative of that?
12x minus 24.
Okay, all you do is evaluate f of 0, f double prime of 0, which I get 0. I'm not happy about it. I know nothing. If it's 0, I just don't know. And if in this case, the second derivative is 0, but it's not a minimum. So I'm going to have to do a first derivative test on this one, because I don't have a way of knowing. Because that was one of my critical points. I'm not done. Let's evaluate at 3. So that's 12 times 9 minus 24 times 3. Does anybody know what 12 times 9 is? 108. You guys are quick. What's 24 times 3? 72. Is this positive or negative? That means that my function would be concave up, which means that this would be a minimum. Now, some of you may not believe me that at the second, I'm showing you the second derivative test. And at 0, it fails. I can think of another function where the second derivative is 0, and I actually get a minimum. Here, in this case, I didn't get either one. Didn't get a max, min, or anything. I had a horizontal tangent. So what if I took y equals x to the 4th? We know what that looks like. It looks kind of like this. And so what's y prime? 4x cubed. Where's my critical point? Critical point equals 0. So I do the second derivative, which is what? 12x squared. So what's y double prime of 0? It's 0. I know nothing. I have to do a first derivative test on that as well. So both of these had a second derivative of 0. This one didn't have a maximum in there, and this one did have a minimum here. So if the second derivative is 0, you don't know. It's okay, we say that a lot in BC Calc. So I'd have to go back and do a first derivative test. Here's 0. If I put a positive number in there, that's positive. If I put a first derivative test. If I put a negative number and it's negative, since my function is decreasing and increasing, it would be a minimum. can't do the second derivative. Now, I believe on my solutions, I did both tests. You don't have to do both tests. But if you prefer, if it's an easy second derivative, I like to do the second derivative test. Most of the time, you're going to use the first derivative. But I'm telling you, they will find a way to get you to use the second derivative on the exam because they want to test for that. It'll probably be a multiple choice question. And maybe they just gave you the second derivative and gave you the critical points. Hard to say. So, are there questions on homework? Otherwise, you have work time. Work time. You have homework questions? What's on your quiz? Your two theorems. Out of what section? Yep. What's on your quiz are the two theorems you have to know and be able to state. You guys never get that. On your quiz, you have to be able to state the two theorems. It's small, but we want it's a formative one to find out. Oh, I don't want to do 5, but I will. No, I'm just teasing. 9's actually easier, but we'll do 5. I could pull the x into the radical. That might look like blackboard magic. So let's just take the derivative. What are we trying to find? Where this is increasing? Oh, local extreme values. And you would have to graph this to find the absolute max or min. Pardon? No. Okay. It'll be easier than that. Brian, question? Brian. Okay. It's x times the derivative of the second one, which is 1/2 8 minus x squared to the what? Guys, shh. Negative 1/2 times, well, multiply our rates together, negative 2x. I don't like those exponents, plus. And then it's this one, I'm going to change it, well, I'll just write it that way. 8 minus x squared to the 1/2 times the derivative of x, which is what? 1. Okay, let's clean that up. This is probably one where I wouldn't want to do the second derivative. The 2's are going to go. I'm going to get minus x squared in the numerator. This radical will go in the denominator, Natalie. The negative means it goes in the denominator. It's the square root, so it's 8 minus x squared. Is that okay? The negative exponent means this goes in the denominator, and a 1/2 exponent is a square root. I multiplied x times negative x. And that canceled the 2's. And then this is plus the square root of 8 minus x squared. Okay, I have some critical points that are easy. Olivia, where's one easy one? Jay? They're easy to find when I have the denominator equal to what? 8 minus x squared equals 0. X squared equals 8. So x equals the square root of 8 and minus square root of 8. There are two candidates. Okay? Now, let's do the hard part. We're going to set the derivative equal to 0. So 0 equals, well, but I have a trick that it's not that hard. It looks awful, but they're always going to work out like this because in the product rule, you only have 2 terms.
Cross multiply.
I'm going to put one of these on the other side and cross multiply. So x squared, that's what's going to be hard about those optimization problems, is going to be the algebra. Is that okay? Now cross multiply. What happens when I multiply these two radicals together? They cancel. So I get 8 minus x squared equals x squared. The x squareds do not go. I'm going to add x squared to this side and add x squared to that side, and I'm going to get 8 equals what? 2x squared. So x squared, Cole, equals what?
Which equals 2.
So x equals 2 or negative 2. Okay, so we have all these things. What is the square root of 8? Oh, what am I looking for? Max mins? Oh, extreme values. Is that right? So we got a calculator. What's the square root of 8? Who's got a calculator?
We don't use calculators.
Girls, did you make that worse?
2.72. I got it. Just kidding, I have no idea. 2.8, 2.4.
Did you actually do it?
Yeah.
2.8. Good enough.
Pretty close.
Okay, so now,
That's the third, the 2 cubed.
well, I have to put this on my derivative graph. So I have a 2 and negative 2. There's negative 2. There's 2. And then I have to know where that is. That's bigger than this. And this is negative 2.8. And then, because I don't really know what that thing looks like, that's the problem. What happens at these 2.8s and negative 2.8s? I have vertical asymptotes there for my graph. Okay, those are undefined. Because that's division by 0. And then I have to test all my regions. So if I put in, well, I've got another problem. What's got to be true about 8 minus x squared for this even to work? 8 minus, whoops, I'm sorry. 8 minus x squared must be greater than 0. So 8 has to be greater than x squared. So x squared is going to be between, it's going to be less than 8. So x is between the square root of 8 and negative square root of 8. So I can't even, I have a domain issue. It only goes here.
So it's bound.
Well, you can't, it's not bounded. Let's put open circles there because you can't have it equal to 0, can you? Right? You can't square root a negative. So now all I have to do is look inside of here. Let's do the easy one. Like easy first. What happens at 0? Is this positive or negative? That's 0. That's the square root of 8, so this is what? Positive. If you try 2.1, and you'll need a calculator, my guess is that 2.1, that's going to be bigger than that. But I don't know without a calculator. If it's not, no, they're going to be AP problems. You would need a calculator for this because you have to evaluate that. My guess is that that's a negative, but I don't know. In which case then it would be decreasing, increasing, decreasing. I'll loan you one. But I don't know, you got to find the value. So I'll put a question mark there. I don't want to make it look like that. You see what you have to do?
Yeah.
Now, if this is positive, 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 which I don't think it is, because of that negative there, if you square 2.2, I don't know, I'd have to put on a calculator. I don't even have a good feeling for it.